So, Chapter 8 test is tomorrow. I wanted to walk through some of the formatives that we've done this chapter to review a little bit, to go over some that have been missed by several people, and just kind of give you a quick overview of, everything. Make sure you study. So, the balancing equations formative, I would do a couple of these, make sure that you can balance because there are several that you will have to tell how to balance or see if it's balanced correctly, things like that. Um, if any of these formatives are not open when you go to re-look at them, just email me and let me know. I have a hard time telling what you can see and what you cannot see on your end after they have been um, closed and graded. So, again, make sure you know how to balance equations. On the types of reactions, there will be several of these. There will be the generic reactions where it said like A plus BX equals B plus AX. Tell me what type of reaction that is. So go back and make sure you look at those. Also, remember that you can go to my YouTube channel and rewatch all of the notes, or it's probably easier to rewatch them there so you can skip to the parts that you need. There will be reactions given like this here, and it'll say what type of reaction is this. So if we look at some of these here, the first one, number one, I'm looking at that, and on the reactant side, I see two compounds. Two compounds automatically is going to tell me, hey, this is going to be a double replacement. As long as I see two substances on the product side. It could be a synthesis if I have two things for reactants and then one substance over here. But for the most part, it's just going to be a double replacement. Let me look at another double replacement. So down number 7. So if we look at 7, compound, compound, and then the BE and the RB change partners. So that's one way that you can tell it's a double replacement. If we look at, let's say, number 3, a lot of people miss number 3. One thing that I see with number 3, I've got oxygen there. Oxygen is a clue that it might be a combustion reaction. If I look at my products and I see carbon dioxide and water, that automatically tells me it's combustion, so I don't have to worry about anything else. If I look at, let's say, number 4, I've got an element by itself and a compound. So then over here, I've got another element and a compound. That's going to tell me it's a single replacement. The other types for number 6, I've got two things becoming one. So that's going to be synthesizing, or that'll be a synthesis reaction. Let's see if I've got, and number 5, I've got one substance and it's making multiple. That's going to be decomposition. So make sure you know those different types of reactions. For the single reaction, single replacement reaction worksheet, I'll do a couple of these for you. I think 12 was one that a few people missed. Oh, that was a coefficient one. Let's see. Let's just pick out 15 here. 15 has a couple tricks with it. So if we look at 15, we've got Fe plus PbNO32. Now, we have to pay attention to the fact that right here it says use iron 2 to know the charge of iron, because it's one of those D blocks. It can be multiple things. So that iron 2 tells us that Fe's charge, I'm going to write this up here, Fe is plus 2. So then we're going to look at the PbNO32. Pb. Now, Pb is also one that can be multiple things, but if we do our uncrisscrossing, that too would be crisscrossed up and tell us that the charge of Pb is plus 2. Now, if we are looking at the NO3, we can find its charge a couple different ways. We can see, oh, there's a 1 there. So if we uncrisscross that, that tells us -1. Or you can look on your iron chart and look up NO3 and know that it's -1. So now since iron's the one by itself, it's positive, we're going to switch it with a positive. So that means Pb is out by itself plus, and then iron goes with the NO3. The iron is a 2, so the 2 that would be here gets crossed down there. The NO3 is a 1, so that 1 would be crossed down to here. And so since it's a 1, we don't have to write anything. The only other thing to check, the Pb, is it a diatomic? Make sure you remember those diatomics. That's something I'm seeing people missing a lot. So again, write those down if you don't have them written down on your ion chart or your periodic table. It is not a diatomic, so we can just leave it alone. So this would be our answer. And refresher, those diatomics, H, NO, and then all of group 17. So write these guys down as diatomics. All right, the double replacement reaction worksheet. Very similar to the single, except now you have 2 compounds to deal with. So let's just start out looking at number 1 again. Calcium. We're going to break all of these down into ions. So calcium, we can tell right here, or the periodic table, calcium is a +2. OH. Again, we can look here from uncrisscrossing, or on the periodic table, it tells us OH is -1. And then our H3PO4, H, we know is +1. And then PO4, again, you can look on the periodic table or right there, and it tells you -3. So we're going to switch the positives. So for this, we're going to have H will be with the OH. So H with the OH, and that's a 1 and a 1, so we don't have to worry about crisscrossing. Plus, now the Ca is with the PO4. Ca is +2, so that gives us a 2 down there. PO4 is a -3, so we get a 3 there. So that would be our product. So then, now on this one I didn't make you balance, but you could go back and balance. One more thing. Remember that HOH is water. You can leave it like that, or you can write H2O. I don't care. But remember, if you see H2O written here, break it down as H and OH. Let's do one more of these. Let's look at number 8. So number 8, we've got aluminum. Aluminum, for some reason, people have missed a lot throughout. It is a +3. So maybe highlight that or mark that down somewhere, because a lot of people are not remembering or looking up aluminum for some reason. So aluminum, that right there tells us it's +3, or it's in group 13. Then we've got SO4, which right there tells us it's -2, or your ion chart. Then we've got Ca, which is a +2, and then our PO4, which is a -3. We're going to cross, or we're going to switch our positives. So Ca will be with the SO4. That's a 2 and that's a 2, so we don't have to worry about crisscross. Plus aluminum and PO4, 3 and 3. So again, we don't have to worry about crisscrossing. So this would be our product for number 8. Now for the word equation worksheet that seem to be difficult for a lot of people. We'll do a couple of these. Let's do number 4, potassium, which is K, reacts with chlorine. And this hurt a lot of people. Chlorine's diatomic because it's in group 17. So I'm going to put Cl2 to form. Now the only thing that they can do here is combine together. This is going to have to be a synthesis. So K is positive and chlorine is negative. K is +1 and chlorine's -1. So when I crisscross, I just get KCl. Then the other thing it asks you to do on this worksheet is to balance. So once I have that written out, then I have to go back and balance. Well, if I've got I'm going to use a different color. If I've got 2 chlorines here, I needed 2 out there to give me 2 chlorines on the product side. Now that gives me 2 Ks on the product side, so I'm going to have to come back and put a 2 there. So this would be my answer for number 4. Let's do one more. Let's go down to number 8. Number 8, people missed because they forgot some naming rules. So hydrogen. Hydrogen's diatomic, so make sure you write it as H2, plus nitrogen monoxide. That's going to be one of those simple prefix things. So it's just NO. Mono means 1, so we've got 1 oxygen. React to form. So this one is going to be a single replacement because we have an element by itself and a compound. Hydrogen is a +1. Nitrogen is a +3. And oxygen is a -2. Now, it doesn't really show up that way because this is a, I'm blanking, a compound that's not ionic. All right, so we're going to pull N out by itself, and we're going to put hydrogen with the oxygen. Hydrogen's +1, oxygen's -2, so that gives us H2O. Nitrogen is diatomic. Then we would have to go back and balance this. Our hydrogens are fine. Our oxygens are fine. We only need to fix the nitrogen. So 2 there, 2 there. But that messes up our oxygens. So we're going to have to put a 2 on this side to get now 2 oxygens on the product side, which then messes up our hydrogens. So we have to come back and put a 2 there. Then that would be our answer for number 8. Our last section was about the activity series or determining reactivity. Will things react with each other? So you have to use this chart. If you're looking at comparing positives, you're going to use the first chart. If you're comparing negatives, use the second one. So, number 1, will the following react? Ag is positive, so we're going to compare it with K. Since Ag is by itself, it has to be higher than K for this to react. So we're going to find Ag's down here, and then K, hold on. Ag's at the bottom, and then K is all the way at the top. So Ag is not higher than K, so this will not happen. Another one, let's look at number 7. For some reason, a lot of people missed number 7. We're looking at Pb, which would be positive, and comparing it with K. Pb, same thing, is lower than K, so that will not happen. Let's look at number 4. The one by itself is chlorine and it's negative, so we have to compare it with the negative in the compound, which is I. So we're going to come to this second chart. Chlorine is higher than I. So yes, number 4 would happen. And that's all you're going to have to do on these determining reactivity ones. Okay, so make sure you study. It is a 40-minute test. It does have to be completed by 1:30 tomorrow. It is open note, but it is rather long, so you won't have a lot of time to flip and look and all those good things. So let me know if you have any questions before the test, and good luck.